Hey guys, I thought to get through content in the videos, it would be better for me to work on example problems rather than reading what you can read in the textbook, and looking at outside materials should give you the idea, and then watching me work through problems should help you go from there. So we're going to just jump straight into it. 7.1. The first problem or type of problem you're asked to do is to simplify expressions. So I've got one here that's moderately difficult in terms of that type of step. So we have sine of t over 1 minus cosine t, all of that minus cosecant of t. So the first thing I want to do is I want to convert everything into sine and cosine. So you can see here the only thing I needed to convert is cosecant into 1 over sine of t. Now I've got two separate fractions. I want to put those together into one fraction, basically having the so I take the two separate pieces and I need to give them a common denominator. If you look at the next two lines here, all I did was multiply each fraction by the denominator of the opposite or the other fraction in both the numerator and the denominator. That's what's happening here and here. And that gives me my bottom line here. That's not simplified completely still. It's just that they now have a common denominator, so I'm going to put them together. Okay, I debated whether or not I should tell you guys what I'm going to tell you now, or I should have just restarted the video, but I want you to know what happened here. So I got to this point, I put the fractions together since they had the common denominator, and I realized there's not really much I can do here with the way that this looks, except that this right here, this 1 minus cosine of t, it's kind of like having a square root in the denominator. I don't really like having that there. I feel like I could probably do something with it. So what I did when I paused the video to write the next step was I quickly jotted down what I'm thinking would work better, and I realized, yeah, no, that's a much better way to work this out. So I'm leaving this first step in the video because I want you guys to see that this is what solving identities, or simplifying and solving identities, is like. You try something, sometimes it works, sometimes it doesn't. So from here, I'm going to actually restart this problem and show you guys how that it will work out much prettier, basically, than what we have right now, because what we have right now can't be simplified much more. I mean, of course it can do a little bit, like distributing this one, but that's it. So give me a second. First thing you'll notice here is that what I did was not to touch the second fraction, the cosecant, or second term's cosecant of t. I actually wanted to multiply both the numerator and the denominator by the conjugate of 1 minus cosine of t. Let me write that out. Okay, that's the term, a little bit of notes about it. You can look more into that on your own if you need to. So I multiply by the conjugate, and what we get in our denominator will look familiar if you looked through the identities notes already. Okay, multiplied out all of those terms. In the numerator, I will distribute that sine of t in just a second, but I wanted you guys to see this step first. All right. 1 minus cosine squared of t converts into sine squared of t. We talked about this in the Pythagorean identities. I don't really want to write in these notes too much, but that is in this section right here. 1 minus cosine squared equals sine squared. So now I'm going to move forward. I'm going to, hopefully we notice that in all of this, there are some pieces that we can basically cancel out. So I'm going to do that right now. Just FYI, those are the pieces we can cancel. But because they're in the fraction kind of joined together like that, I'm going to split the fraction first. When I split the fraction, you can see that I can cancel out one sign out of both the numerator and denominator of each of these pieces. And the next line will look like... Okay, so what we have here, when I cancel out those pieces, 1 over sine of t plus cosine of t over sine of t minus cosecant of t. My next step that I like to do whenever I'm looking at trig functions, if you'll notice, I believe in the notes that I put online, I like to, I'm going to write this down on the side as well. convert everything into sine and cosine. So we have one term here that is not in terms of sine and cosine. So when I convert it into a sine term, then you can see that something really nice shows up here. 1 over sine of t right here and 1 over sine of t here are being subtracted from each other, meaning that they cancel out, and we are left with that middle term. Our final expression simplifies down to cotangent of t. Basically, the expression that we were given in the problem, sine of t over 1 minus cosine of t minus cosecant of t, gives us cotangent of t. It's when you're looking at this final statement here, it doesn't look that intense or that much work, and really all that we did is the basic algebra. We did not do really any trig beyond converting between cosine and sine to cotangent, or cosecant to secant, or cosecant to 1 over sine. There's really no trig here. It's just doing a lot of little algebra steps. Next type of problem you'll see, you're asked to verify an identity. There's so many different types of problems you can see here, so I'm not going to do all of them with you. I'm simply going to do one with a different type of formula than we've worked with before. It is actually in the notes from what I've posted online. Let's flip back over to that. Actually, let me explain what's happening here. So you have an identity where you have cosine minus sine and cosine plus sine. It looks simple enough, but there's a big problem here. Our problem is that this term and this term, those angle measures are negative x, whereas these angle measures are positive x. That is not okay. We cannot work with our problems like this. So the next strategy, very important. Actually, let me pause it. So as I mentioned, you've got these two angles here that are negative. These are positive. A big strategy that you want to use, make sure all your angles are the same. So I'm going to go back to the other notes. Looking at these even-odd identities, we're not going to worry about the extra information here. We just need to notice that cosine of negative x equals cosine of x. So I'm going to flip back over and write that down. So I've got that written on the side to refer back to it if I need it. And here I see that sine of negative x equals negative sine of x. Now that I've got these formulas written down, I can actually use them to simplify one side of my equation here. I replaced it. Please remember that I like to use red to indicate a new change in the line. And notice that I leave the right-hand side blank. A lot of the times when you see identities worked out like this, you'll see people leave one side like that just as equals blank or blank equals, because we're not touching that side. We'll talk about that some other time. So once I've done this, it's actually really simple. You can see that I've got a double negative, so I'm going to convert that. When I convert that double negative to a positive, then what you're seeing is the left-hand side of the equation is the same as the right-hand side of the equation. That means that you have verified the identity. We're good to go. You can put a little box at the end to show that you're done. That's a standard. One last note that your textbook likes to do is they will refer to this as the LHS for left-hand side or the RHS for right-hand side. So I mentioned that people will leave a side blank. Basically, some people believe that when you're verifying identities, you can only work on one side of the equation. And only one side, because if you work on both, then you're not following the rules. That's a pretty traditionalist way of doing it. Some people will work on both sides. I am fine doing that. I don't mind working with both sides of the equal sign, but you can never move terms across the equal sign. If you do that, if you're moving across this line, basically, you are not verifying an identity. You're doing something different. Just throwing that out there. So let me write that down. All right, I got that note written down for you if you want to pause the video and get that, and we'll move on. All right, next type of problem you might be asked to do is substituting into an expression and then simplifying. So I've got one here, 9 minus x squared if x equals 3 sine of theta. So the first thing I'm going to do is plug in. Plugged in looks like this. Then I'm going to just follow the most basic steps. Okay, from here, I want to factor out that 9 because there's a 9 in both this term and this term. When I do this, I get 1 minus sine squared of theta, which we should remember. From here, 1 minus sine squared of theta is equal to cosine squared of theta. So this is what the expression would look like. I actually took this from the back of the textbook, or from the problems in the back of the section. However, I am using my mobile textbook, and it is written very, very poorly. I don't know those of you who have looked at the mobile version of the textbook. It looked to me like the problem was this, but it turns out the problem actually has a square root on it. So the problem would just imagine that there's a square root throughout the rest of this work. It doesn't change the work until you get down to this last step. We should know that we can take the square root of 9 and the square root of cosine squared of theta, and that will give us 3 cosine of theta, which would be the final answer if you're looking at the problem from the textbook. That one's a pretty clear problem, just algebra. By the way, guys, when I say something's pretty clear, I'm not trying to say this should be super easy for you guys. I'm trying to say don't overthink these things. That's all. All right, the next one, the next type of problem will ask you, or could ask you, to graphically identify that the equation's an identity. So I took the left-hand side of the equation here, and this is the right-hand side of the equation. So the equation you'll be looking at is 1 minus 2, wait, am I recording? Oops, hang on a second, guys. I've lost the ability to record. Where did it go? Oh no, what's happening? Is my recorder? Is it recording? Did it stop recording? Where did it go? No. Is it still recording? It's still recording. Oops. Sorry, guys. The recorder just like popped off the screen for some reason. Sorry. I'm continuing. So anyway, the equation you're looking at is 1 minus 2 sine squared of x equals cosine squared of x minus sine squared of x. And see, ignore that. So I just have that typed out for you. And so there's the left-hand side and there's the right-hand side. So the way that you can check if they're an identity, and I mentioned this before, is if both graphs are in the same exact spot, then they are an identity. So here's the right-hand side, and here's the left-hand side. They're in the same exact spot, which means that they are an identity because they share the same value, y value, for every input, for every x value. And like I said, I did mention that before, but I wanted you to see this. I wanted you to see what that could look like. And let me pause it and do a new set of graphs, or a new equation. Oh, before I do a new equation, just please note that this is actually one of your identities from before. So if I go to your OneNote, notes from before, and we look at the double and half angle identities, you have that cosine of 2 theta can be cosine squared minus sine squared, and it can be 1 minus 2 sine squared. Those are the same, and we were able to just see that graphically here. Okay. All right, I've got one here. Sine of x plus cosine of x, all of that squared, equals 1. That looks a lot like the identity sine squared plus cosine squared equals 1, and we know that's true. So is this one an identity as well? What I've got, my left-hand side here and my right-hand side here. There's the left-hand side equation. Looks good. It's just a curve, a wave. And here's my right-hand side equation. Not the same at all, because I told you guys you can't just put that square into the two pieces. It's the same idea. They do not overlap. They do not coincide. These are not an identity. It's not the same thing. All right. To summarize what we just talked about with the graphs, I've got them shown here. 1 minus sine squared of theta on the left-hand side and cosine squared minus sine squared of theta. They are very clearly equal, so I put a question mark to say that I was testing it and then a check to show that I actually got it, or that they are the same. All the values coincide. Then I wrote down example 2, cosine of x plus sine of x squared here, and then 1 shown here. I'll actually highlight that for you guys so that way it's clear that that's there in the middle, and I'll highlight it on this one. I feel like that purple kind of blends in. Then when I put those two together to test if they are equal, they are definitely not. So that's what I get here. That identity is not true. It's not an identity. It does have solutions, so it is an equation that does work because there are solutions here and here and here and so on and so forth. And we'll talk about how to solve those later. That covers the type of problems that you might see in 7.1.